Okay, this is competency-based exam number 1. And the first one deals with imaginary numbers. So just a really quick review. Oh, that's not what I meant to do. Okay. So I is equal to the square root of -1. If I had I squared, that would be the square root of -1 squared, which is just -1. And then I to the third is just these two multiplied together, an I and an I squared. And I times -1 is -I. And then I to the fourth would be this times itself, which is just 1, and then it repeats after that. I to the fifth is the same as I. I to the sixth is the same as I squared. Okay, what if I had I to the 57th? What is that going to be? Well, let's just divide it by 4. So if I do 57 divided by 4, I get 14.25, which means I went all the way through the list 14 times, and my remainder is 1/4. So that would be the same as I. Right? I finished the whole list 15 times, and then I did 1/4 of the list. So if I had I to the 263rd, I would take 263 and divide by 4, and I get 65.75, which means I went through the list 65 times. And what is 3/4 of the list? 3, which would be -1. Or -I. Just listen to what I mean. Don't listen to what I say. Okay, so part of that is going to come into play in this problem. The other is, how do I get I out of a denominator? We use conjugates. So what is the conjugate for 5 minus 2i? 5 plus 2i. So I will multiply the bottom by 5 plus 2i. Am I allowed to do that? If I do it to the top, why? Why is this all of a sudden legal? It's just the number 1 in fancy clothes. Does that make sense? Okay. So the numerator, I get -30 minus 12i, and then plus 5i, and then plus 2i squared. Okay. Well, what is I squared? -1. So I can get rid of the I squared and change this to a negative. -30 minus 12 is -42, minus 2 is -44. Oh, 12i. Okay, so -30 minus 2 is -32. And then -12i and 5i is -7i. All right, the denominator turns out to be really easy. I get 25, and then this will be, that will be 10i, and this will be -10i, and this will be -4i squared. But 10i minus 10i goes away, and we knew that was going to happen because they're conjugates. And then -4i squared turns into plus 4. 25 plus 4 is 29. Okay, so this has turned into that. I squared is always -1. And then I need to add the I to it. Can I add those? If I have a common denominator. So I put this over 29, and I need a 29 on top. So 29i minus 32 minus 7i. These are like terms. So it would be negative 32 plus 22i. And it's all over 29, but you'll notice it wants me to put the real portion separate from the I portion. So both of these are going to be over 29. Okay. Do I dare plug it in? So I need a fraction. Negative 32 over 29. And then 22. Oh, that's no good. 22 over 29. Okay, cross your fingers. Hey! I passed. Okay, any questions there? Is there a way to do another problem just to check? I don't know, I guess you could reload the page. Okay, true or false? The imaginary number square root of 2i is a solution to the equation x to the fourth minus 4. Now, you have to be careful here. Notice that the square root does not capture the I. So the way I would write this is I root 2. I'm not sure why they wrote it the other way around. Well, I guess that fits the format that they've been using. So, can we factor x to the fourth minus 4? Yes. X squared plus 2 and x squared minus 2. Now, these are both difference of perfect squares as long as you count it as the square root of 2. So this would be x minus root 2 and x plus root 2. And then this one factors with an I. X minus I root 2 and x plus I root 2. What's that? Because this has two answers, and it wants to know a single root. If it was x squared minus 9, then I would factor it into x minus the square root of 9 and x plus the square root of 9. But this number does not square root, but the answer still exists. Another way to look at it, maybe this will make more sense to you, is if I had x squared plus 2 equals 0, and I just solved, I would get subtract 2, x squared equals negative 2, and then when I square root, I get plus or minus, the negative turns into an I root 2. Does that make more sense? Okay. Any questions there? I wonder what happens if I try to refresh this. Same problem. Capital T. Won't it let me? I'm stuck. Oh, there are more problems. Okay. Determine all of the complex solutions to the equation below. Can I say x plus 7 is equal to negative 6 and x plus 1 is equal to negative 6? No, that only works if the answer is 0. Okay, if the answer is a 6, that's not true. What do I need to do? I need to set it equal to 0, and then I would have 2 factors plus 6, which means I need to convert this into quadratic form, which is x squared plus 8x plus 7. Then I add the 6 over. You guys handle those in your head? Okay. X squared plus 8x plus 13. Now what? Are there two numbers that factor or add, are there two numbers that multiply to be 13 and add to be 8? No. And I knew that was going to happen because it told me my solutions are complex. So I knew it wasn't going to factor. So quadratic formula. -8 plus or minus the square root of 64, then -4 times 1 times 13. So that's minus 52. Something's not right. That's not going to be complex. What did I do wrong? Let me graph it. Which is something you won't be able to do. Well, that definitely hits the x-axis. Okay. So what it's saying is all real numbers are actually complex numbers. So complex numbers are in the form a plus bi. So what it's saying is find the solutions. They might be real, they might be imaginary. So in this case, there is no I, but technically real numbers are complex numbers as well. Okay, divide that by 2. 64 minus 52 is going to be 12. So -8 plus or minus the square root of 12 over 2. Can I simplify the square root of 12? Yes. What perfect square is inside 12? 4. So I square root the 4, and I get a 2. And then what is left over? A 3 over 2. And then that 2 cancels those. So the answer is -4 plus or minus root 3. So you'll have to put in -4 plus root 3 and then -4 minus root 3. Do you want to see one that has i's in it, or are you good with those? Yes? You want to see i's? Okay. So let's do 3x squared plus 4x. And then how do you guarantee that a graph misses the x-axis? Just make the y-intercept really big, right? And if it's not big enough, make it bigger. So we're going way big, 20. Let me check this. Can't even see it. Perfect. All right. -4 plus or minus the square root of 16, and then -4 times 3. Oh yeah, that's way big. So -4 times 3 times 20 is -240 over 6. And so we get -4 plus or minus the square root of -224 over 6. So what goes into 224? Well, 2 and 1, 12. 2 and 56. 2 and 28. 2 and 14. 2 and 7. So I can scratch off anything that factored. Do I have any pairs? Pair of 2's there, pair of 2's there, with a 14 left over. So, -4 plus or minus 4 times the square root of 14 over 6. Oh, and an I. So all of those share a 2. Notice I didn't touch the 14 on the inside, because it's not actually a 2 in there, it's the square root of 2. So, -2 plus or minus 2i root 14 over 3. And then you would just split those. You would do a positive version, comma, negative version. Make sense? Okay. All right. Determine the real number solutions to the equation below. Enter each solution separated by a comma. If there are no solutions, type no solutions. So, what is x not allowed to equal? 1 and -1. Those are not possible. So if one of our answers or both of our answers are in that list, then we just throw them away. Okay, how do we solve this? We need a common denominator. The common denominator is going to be x minus 1 and x plus 1. So this factors into that. Right? So one of them can't be 1 and one of them can't be -1. If that's my common denominator, what does the left side need? It needs an x plus 1. Okay. What does the middle fraction need? Nothing. It already has them all. Okay. And what does the 7 need? Both. Now, should I write it like this? No. Write it like this to save yourself some steps. So, x squared minus 1, x squared minus 1. Now, what do I do with the denominator? I just ditch it. I don't need it anymore. Right? If I have 3 fractions in an equation and they're all divided by 7, then I don't need the divide by 7 anymore. Right? A divided by 7 plus B divided by 7 equals C divided by 7 is the same as A plus B equals C. So I ditch all of the denominators, remembering that. So on the left side, 8x squared plus 8x plus 8 is equal to 7x squared minus 7. Let's move everything to the left. That gives me x squared plus 8x plus 15. Does that factor? X plus 5 and x plus 3. Which gives me x is equal to -5 and -3. Are those answers okay? Yes. So both answers work. Okay, any questions on that one? Find a common denominator, ditch the denominators, but remember the domain restrictions, and then you'll end up with a quadratic or some other equation. Just solve it. All right, well, let me go to page 3. Yes. Okay, determine all of the real number solutions to the equation below. Each solution enter each solution in exact form, separate by commas. What does it mean, exact form? No decimals that go on outside the page, right? So If you have to use the quadratic formula and the answer has square roots in it, leave it in square root form. Okay, so it's sort of like a polynomial. I mean, technically that's not a polynomial, but we have a times b times c equals 0. So we can just set each one equal to 0. What makes the first one equal 0? Well, when does the square root equal 0? When the inside equals 0. So when does 4x plus 1 equal 0? Subtract the 1 and divide by 4 and you get negative 1/4. Okay. So let's plug this one into the quadratic formula, because I don't think it's going to well, let's try factoring it. It might. So we put in 3x squared and negative 2, multiply those together, negative 6x squared. Are there factors of negative 6 that add to be 2? No. What does that tell us about these solutions? It might not hit the x-axis. It tells us the answers are not fractions. So they could be irrational, some nasty decimal, or imaginary. So it might still hit the x-axis, we don't know yet. But we know the answers are not nice fractions. So instead, we need to plug that into the quadratic formula. Negative 2 plus or minus the square root of 4. And then off to the side, I like to write negative 4 times 3 times negative 2. That would be 24 plus 24 over 6. So this gives me a 28. Are there any perfect squares inside 28? 4. So we square root the 4, and it becomes a 2. What's left over? A 7. So what I'm saying is 28 is 2 times 2 times 7. We bring out the 2 times 2, and I get negative 2 plus or minus 2 root 7 over 6. These all share a 2, so negative 1 plus or minus the square root of 7 over 6. 3 over 3, thank you. Okay. Let's see if this factors. 9x squared, 4, 36x squared. Are there factors of 36 that add to be negative 12? So 1 and 36, no. 2 and 18, no. 3 and 12, 4 and 9, 6 and 6. So the 6's will work. Negative 6x, negative 6x. What does this share? 3x. Pull out a 3 and an x, and I get 3x minus 2. Pull out a 3 and an x, and I get negative 2. So 3x minus 2 and 3x minus 2. So x is 2/3. Okay. There's one more thing we need to pay attention to. We have 4 answers. So we have 2 answers here. And this is it has a multiplicity of 2. It's a duplicate answer. And then we have this. However, this equation does have a domain restriction. What is it? Right here. What numbers am I not allowed to plug in? Well, when we solved that, we got x equals negative 1/4, which is true. If you plug in negative 1/4, that piece of the equation will equal 0, and the entire equation will equal 0. However, any number smaller than that will create an I in there, and I'm not allowed to use those numbers. They work in the other pieces of the equation, but not in that one. So what we say is the domain is 4x plus 1 must be greater than or equal to 0. So I subtract 1 and divide by 4, and I get x is greater than or equal to negative 1/4. Does this satisfy that? Yes. So 2/3 is a valid solution. Does this satisfy that? Well, I don't know. Let's plug it in. So negative 1 plus the square root of 7. And then I divide that by 3, and I get 0.5. Does that work? Yes. Negative 1 minus the square root of 7 divided by 3 is negative 1.21. No. So this piece gets thrown out because it does not satisfy the domain restriction. Does that make sense? Okay. So you would type in, you would type in 1/4 or negative 1/4, 2/3, and then what was that? Negative 1 plus root 7 over 3. Yeah. You just don't type in that third one or the fourth one. Determine all the complex number solutions. Okay. We add the 5 over x to the 4th plus 6x squared plus 5. Does that factor? Yes. X squared plus 5 and x squared plus 1. And then how do those factor? You can either factor them or you can just solve them. If this was x squared minus 1, how would it factor? X plus 1 and x minus 1. When I change that to a plus, what happens? It's still x plus 1 and x minus 1, but now we put an I next to those. So it would be x plus 1i and x minus 1i. Or, if you forget that, just do x squared plus 1 equals 0, subtract 1, x squared equals negative 1, square root. The square root gives us plus or minus, and the negative 1 gives us I. So I and negative I. How would you factor the next one? Well, it would be x plus x minus, and because this is positive, I know there are i's in there. And then what times itself is 5? The square root of 5. Or, if you prefer the other way, just subtract 5. X squared equals negative 5. Take the square root. The square root gives us plus or minus. And then I comes out from the negative root 5. So there are 4 answers. I root 5, negative I root 5, I, and negative I. Does that make sense? And it's totally possible. What's that? Yeah. So it's totally possible that you end up with something like this. X squared minus 4 and x squared plus 7. And if you practice this enough, you'll get used to it. This is just going to be plus or minus 2. And this one's going to be plus or minus, and I would put the I first. I root 7. Because 7 does not square root. So what number times itself is 7? The square root of 7. All right. Last one. I can't see the whole. There we go. Nope. Yeah. Okay, what is the domain of the function? The domain of the function is just going to be all of the x's. So -2, -5, -6, 2, 4, -3, 5, -7, -1, and 0. And if something happens more than once, you don't need to list it more than once. Okay. So the function g is defined by that's a piecewise function. Have you guys seen these before? Last year? So what this is saying is you have 3 functions. One of them looks like this. One of them looks like this. And one of them looks like y equals 5. But each function is cut into pieces, and those pieces combine to be a single function. So this one goes from -5 to -2. So that chunk here gets moved down like that. And then the next one occurs from 4 to 6. So this chunk here gets moved to there. And then this one is just a single point. So 1, 2, that point right there. So that point right there. Okay. So it wants to know what the domain of the function is. Well, that's really easy. They told us. It's right here. So the domain is going to be x equals from -5 to -2. Does -5 count? It says equal to, so yes, bracket. And then does -2 count? No. Union, and I'll have to click inside there and see how they want you to type that in. Union 4 to 6, and neither of those count. Union, it's just 2, but I'm not sure how they want you to write that. So I'll click inside that and see if I can get it to work. All right. All right. So, so this one, and then -5. Oh boy. So -5 comma, what was it? -2. Okay, so there is a union symbol. No. Union. My guess is just 2. Union. And then this one. 4 to 6. Try again. So maybe I don't see a double bracket. Okay. So do you see what I did with the single point? I did bracket to bracket, and that's not an option here, so I had to use the keyboard, which kind of stinks. Oh, there's one more. I didn't know that. Okay. Two more. All right. How do we break domains? What can we do to break a domain? 0 on the bottom or a negative inside a square root. Okay? So when I have a square root, what do I do with this to find the domain? I take whatever that is and I write greater than or equal to 0 and then solve it. So over here, this tells me 3x plus 4 must be greater than or equal to 0. Right, but I also know that 3x plus 4 cannot equal 0, because if it does, then the square root equals 0, and since it's in the denominator, the whole denominator would equal 0, so I need to go in and get rid of that. Do you guys understand that one? Normally it's greater than or equal to 0 unless it's on the bottom, and then it's strictly greater than 0. So subtract 4. X is greater than negative 4/3. Okay? And then on the other one, 3x minus 1 equals 0. Add 1 and divide by 3, and I get x equals 1/3. So we have to compare the two. Does this work over here? Yes. So on the number line, I have negative 4/3 and I have 1/3. Okay. I know everything greater than this is a solution, except 1/3 is not a solution. How would we describe that using interval notation? Negative 4/3 to 1/3. Does negative 4/3 count? No. Parenthesis. Does 1/3 count? No. Union that. 1/3 to infinity. Does 1/3 count? No. And infinity always gets a parenthesis. Now, what if instead of 1/3, it was x cannot equal negative 3? Then that does not matter. So this is already over here in a portion of the x-axis that is not allowed. So that doesn't have any bearing on it. All right. Okay. How do we find f of 3? Plug 3 in. That's real tough. So 3 squared is 9. 2 times 9 is 18, plus 5 times 3 is 15. 18 and 15 is 33. Minus 3 is 30. Okay. And then let's find f of x plus h. So I take x plus h and I stick it in there and in there. So 2 times x plus h squared plus 5 times x plus h minus 3. Hopefully you can do this in your head. X squared plus 2 copies of xh plus h squared 5x plus 5h minus 3. Oh, I did. I'm good at doing that. Okay. So 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3. And I don't think anything simplifies. Okay, you so ready? Yeah, there's no way to cut that down.